For today's lesson, you'll need the following items. First, a copy of the periodic table of elements. I love you. You can find a copy of this in any chemistry textbook, as well as most biology textbooks, or just Google it. Second, you will need this orbital diagram. I'll provide a link for this diagram in the description of the video. But if you don't want to print it out, you can just draw it out yourself. All you'll need is a center portion for putting protons and neutrons and 3 orbitals or levels surrounding it. The first level needs 2 spaces, or these 2 circles. The second and third level need 8 spaces. So go ahead and hit pause and draw that out if you need to. Thirdly, you'll need a bag of colored candy. I chose Skittles. Taste the rainbow. You'll also need a handy-dandy notebook and a writing utensil. There's mine. I'm going to write my notes on this whiteboard. Anything I write on this whiteboard might be a good idea to write in your handy-dandy notebook. Lastly, I recommend eating a nutritious meal before getting started. That way, you won't eat all your Skittles before you have to use them. All right, if you have all those things, let's get started. You may be wondering, what does chemistry have to do with biology? But the reality is, when you break down biology to its simplest parts, it is just a series of chemical reactions. So to understand the basics of biology, you first have to understand the elements of chemistry. The fundamental unit of chemistry is the atom. Atoms are made of subatomic particles, which we're going to abbreviate SAP. Now there are 3 types of subatomic particles: protons, neutrons, and electrons. Each subatomic particle is slightly different in its charge, mass, and location. Protons have a positive charge and a mass of 1 atomic mass unit, and they are located in the nucleus. Each neutron does not have a charge, has a 0 charge, but also has a mass of 1 atomic mass unit and is also located in the nucleus. Electrons have a charge, a negative charge, but their mass is negligible, so we're going to say they have 0 atomic mass units. They are located in orbitals, which circle around the nucleus. Now the number of protons, neutrons, and electrons an atom has will give it different properties. Protons define the type of atom, and types of atoms are called elements. So our periodic table of elements, all of these elements have different numbers of protons. Protons are also going to contribute to the charge of an atom and to the mass of an atom. Neutrons are not going to contribute to the charge, but will contribute to the mass. Electrons are not going to attribute to the mass, but will contribute to the charge. We'll get into more of that later. All right, so now we are going to get into our orbital diagrams and our skittles. Dang it, mouse. So go ahead and open your bag of Skittles and dump them all out. What I would do is really quickly sort them by color. Now, designate each of these subatomic particles to be coordinated with one of these candies. So I'm going to have the orange ones as protons, green ones as neutrons, and yellow ones as electrons, because those are the three most abundant I have. Go ahead and eat the other two, or save them for later. We're now going to get into diagramming different types of atoms or elements. Before we get into making diagrams of our atoms, what we're going to have to do is take a closer look at the periodic table of elements. We're going to start by looking at our first element, hydrogen. Now, if we draw a bigger version of what's on the periodic table of elements, you'll notice for hydrogen you have a big H, a number 1 on the top, and then a number below it. The H is called the atomic symbol. Most elements have an atomic symbol that is the first 1 or 2 letters of the element, but not always. The number above it is called the atomic number. The atomic number also equals the number of protons that an atom has. The number below it is the average atomic mass. For the purposes of this exercise, though, we're just going to average or round down to the nearest whole number. Now, actually, with that information, you should be able to diagram what a hydrogen atom looks like. So go ahead, get out your orbital diagram or atomic diagram, and using these subatomic particles, go ahead and make a representation of a hydrogen atom. Remember, the protons and the neutrons go in this center portion called the nucleus, and the electrons go in these orbitals which go around the nucleus. The rule with putting electrons in the orbitals is that you must fill the lowest orbital before you go on to the next one. So go ahead and get out your diagrams and your skittles and do your best to do a hydrogen atom with an atomic weight of 1 and a charge of 0. After giving it a try, unpause the video and we'll show you how to do it. Okay, so if you remember, the atomic number of hydrogen was 1. So that means it has 1 proton. And so, because the proton goes in the nucleus, you're going to put 1 proton there. Now, to determine the number of neutrons, all you have to do is take the atomic mass and subtract the number of protons. Now, we have an atomic mass of 1. You subtract the atomic number, or the number of protons, and that equals 0. So that means we don't have any neutrons. Finally, to determine the number of electrons, all we're going to do is balance out the number of protons with electrons. So since we have 1 proton, we're going to have 1 neutron. And that's going to give us a net charge of 0. So if this is what you made for your hydrogen atom, then this is correct. All right, next we're going to do a helium atom, which is a little more complicated but still simple. Then we'll get into some more complicated ones. So, see if you can do a helium atom. Hit pause and then unpause and we'll show you how to do it. Helium has the atomic number of 2. So, it's going to have 2 protons in its nucleus. Helium has an atomic mass of 4.026. So we're going to round that down to 4. And to determine the number of neutrons, we take the atomic mass of 4, subtract the atomic number of 2, and you get 2. Now to balance this out, we're going to balance out the charge of the 2 protons, which would be plus 2, with 2 electrons, which would be minus 2, and there you have a helium atom. If that's what you had, you did it right. Okay, let's now try one more, and this one will be a little trickier. Let's try boron, which is the atomic number 5. So go ahead and hit pause and see if you can do boron. Okay, so boron has the atomic number of 5, which means it's going to have 5 protons in the nucleus. Boron has an atomic mass of 10.8. So we're going to round that up to 11. If it has an atomic mass of 11, and you have 5 protons, that means you're going to add 6 neutrons. It's getting a little crowded in there. 1, 2, 3, 4, 5, 6. Okay. Now if we're going to balance out the protons, which have a positive charge, with negative charges, then we're going to do 5 electrons. The first 2 go on that first orbital. The next 3 go on this next orbital. And you can space them out for now. Alright, and there you have a boron atom. Up to now, we've been doing models of atoms that have a net charge of 0. Not all atoms have a net charge of 0. Some of them have a positive or negative charge. An element with a charge is called an ion. An ion can have a positive charge, that's called a cation, or it can have a negative charge, which is called an anion. Alright, so now I want to see if you can make a beryllium ion that's a cation. So go ahead and get your diagram out, press pause, and see if you can make a beryllium cation so it has a +1 charge. Alright, you should have a good handle of how to make these by now. To make an ion, we're just going to adjust the third step. The first step is still going to be the same. So we look at beryllium, it is the 4th atom, has atomic number of 4, has 4 protons. It has an atomic mass of 9. 9 minus 4 is 5, so it has 5 neutrons. Okay, so now if we're going to make a cation, we need to have one more proton than we have electrons. So since we have 4 protons, we're going to add 3 electrons. And now we have a beryllium cation. A common mistake is for people to start adding protons. So if I did that, if I just added a proton, this would have a positive charge. But because we changed the protons, it's no longer beryllium, it's boron. So if we're going to make an ion, you can't change the protons. You can only change the electrons. All right, let's give you one more. Why don't you make an anion of lithium? Lithium has an atomic number of 3, a mass of 7, and if we're going to make an anion, it needs to have one more electron than protons. So there we have a lithium anion. All right, so now you know how to make ions. We've made atoms that have a neutral charge, and we've made ions, specifically anions and cations. Now we're going to talk about elements that have different mass. Elements that are the same kind but have different mass are called isotopes. For example, let's make a stable hydrogen ion. If you remember, hydrogen has 1 proton and 1 electron and an atomic mass of 1. Isotopes are written out by writing out the element with a hyphen and then the mass. So this is hydrogen 1. Hydrogen also has a couple other of naturally occurring isotopes, including hydrogen 2. Hydrogen 2 is also known as deuterium. Hydrogen 2 is different than hydrogen 1 in that it has another neutron. If you remember, neutrons have a mass of 1 atomic mass unit, and so do protons. So the mass of this hydrogen is 1, 2. Deuterium is an example of a stable isotope, meaning it does not decay or give off radioactive particles. Another isotope of hydrogen is hydrogen 3, also known as tritium. Hydrogen 3 is radioactive because it is not stable in this configuration and will give off radioactive particles. Hydrogen 1, hydrogen 2, and hydrogen 3 are all isotopes. Hydrogen 1 and 2 are stable, and hydrogen 3 is radioactive. All right, let's give you another one and have you practice. All right, so what I want you to do is do a boron 12. Make the isotope boron 12. Go ahead and hit pause and see if you did it right. All right, boron 12, if you look at the periodic table of elements, boron has the atomic number of 5. And we're going to say this is neutral, so we'll add our 5 electrons. And we said boron 12, so 12 minus 5 is 7, so it must have 7 neutrons. That is boron 12. Let's do one more. Let's do lithium 6. Lithium has 3 protons. It's the atomic number of 3. 3 electrons. And now to get to 6, you do 6 minus 3, 3 neutrons. There you have lithium 6. So why is all this important? Well, the way that these subatomic particles are arranged affects how these elements interact with each other in interactions called reactions. So, an important thing to talk about here is what's called the octet rule. The octet rule is that elements want to have a stable configuration, meaning they want these orbitals to be filled. Okay, the first orbital has 2 on there. The outer orbital of electrons is called the valence electrons, or the valence shell. This is what gives the reactivity of the element. An element that has their valence electron orbital filled is going to be in a stable state. So if you remember helium has 2 protons, 2 electrons, and 2 electrons. This orbital is filled, so it is in a stable configuration and does not react with other elements. Hydrogen, on the other hand, has 1 electron but needs 1 electron to become stable. So hydrogen is very reactive. What hydrogen will do to form stable electrons is it will share electrons. So if you have 2 hydrogen atoms, one here and one here, what they will do is share their 1 electron each until they both have 2 because they're sharing 1. Now this is the same for other elements such as lithium. Lithium has 3 electrons, 1 in the outer valence shell. What lithium can do to make itself have a stable octet is to get rid of that electron. But now it's an ion. It has a charge. And so sometimes ions will form ionic bonds. Lithium has a positive 1 charge, so it may form a bond with a chlorine cation and form an ionic bond. Ionic bonds are one type of bonds. Covalent bonds, where those electrons are shared, is another type of bond. Those bonds are what hold elements together in things called compounds. Alright, so finally, let's talk about carbon. Let's make the carbon atom and talk about why it is so unique. Carbon has an atomic number of 6, an atomic mass of 12. It's getting crowded. And so it has 1, 2, 3, 4, 5, 6. In order to have that outer shell filled, it needs 4 electrons. What makes carbon so important is that it can form 4 covalent bonds. So let's say you had 4 hydrogen molecules. These 4 hydrogen molecules can form 4 covalent bonds. This is an atomic diagram of what's called methane. Now, carbon can also form covalent bonds with itself. In fact, it can form a covalent bond with a carbon here and a carbon here and still have 2 other spaces to form covalent bonds with other atoms. So it can form these long chains of carbon, and those chains of carbon can form structures like rings, which are found in carbohydrates, long chains, which are found in fatty acids, which make up lipids, and chains of carbon and nitrogen, which make up amino acids, which are part of proteins. They're also very important for nucleic acids, and these 4 are called the macromolecules of life. So the word organic refers to substances that are important for life because they have carbon atoms at the center of these macromolecules, which help form the functions of life. Okay, so these fundamentals of chemistry will help you learn more about biology. Alright, now that you've finished, go ahead and eat all the candy. This stuff's delicious. I love Skittles. Delicious. All right. Hope you have a good day. Hope you enjoyed this lesson. Come back more for more videos.